Hello and welcome back to Chemistry Talk. Today we'll be continuing our discussion of solutions and concentration expressions by talking about dilutions. I know these all kind of have similar sounding words, but they're completely different. So we talked about solutions and concentration expressions, more on that today, but we're going to talk about dilutions. So a dilution is basically taking some volume of a concentrated solution, mixing it with another volume of a different concentrated solution, and solving for the second concentration. You can, any of those variables could be switched. Usually I write the formula as the concentration of the first one and the volume of the first one equals the concentration of the second solution times the volume of the second solution. So that's the formula. So you could be given the volume of the initial solution and with the concentration and asked to find the volume of a second concentrated solution. You just got to be careful with the wording. If it says with, you're diluting something with something, then your second volume is going to include your first volume. So V2 would actually be the sum of the volumes. Just depends on the wording. It's got to be careful. I think I have a couple of examples of that. So I have 4 examples, so let's get started. These range from difficulty, but all pretty much the same. So how much water is needed to prepare 500 milliliters of a 0.5 molar sodium hydroxide solution from a 2-meter solution? Okay, so let's see what we're given. All right, we're given the concentration of our first solution. That would be 2 molar. This is our original solution. We don't know the volume of the first solution. We're looking for the volume of water. So that's what's contained in the stock solution. We don't know that. We know the concentration of the resulting solution is 0.5 molar. Notice that the concentrations are both in molar, and that's fine. This could be a mass percent, a molal, as long as they're the same, it doesn't matter. And the second volume is 500 mils. However, it's important to keep in mind that that 500 mils includes the water from volume 1. So the volume 2 actually equals volume 1 plus the water that we're looking for. So we're going to use that to solve. So let me solve for volume 1 using my C1, V1, C2, V2 formula. If I'm solving for V1 and I manipulate that algebraically, I get V1 is equal to C2, V2 over C1. So V1 would equal our second concentration, 0.5 molar, times our second volume, 500 mils. That includes our water. So we'll subtract that, the initial volume, to find that, over our initial concentration, 2. So we get V1 equals 125 mils. So that's what V1 equals. I'm looking for how much water. So I need to subtract V1 from V2. So using this, I know that V2 is 500 mils. I know that V1 is 125 mils, and that includes the water. So to isolate the water as, let's say, a variable, I would subtract 125 from both sides and get that we have 325 mils, 75 mils of water. And that is our answer. So not hard, but you just got to be careful with the wording. to make sure that you're getting what the question is asking for. Okay, moving on. If 25 mils of an 85% phosphoric acid solution is mixed with 80 mils of water, what's the percent concentration of the diluted solution? Okay, well, once again, this is just a dilution problem. It's C1V1 equals C2V2. Notice now we're dealing with a mass percent. So that's another concentration expression, and we're looking for the percent concentration. So we're not changing expressions, so the percent is fine. Remember, you only have to worry about changing the concentration expression when you are given a mass percent or asked for a molarity. You have to change the expression. So we have an initial volume of 25 milliliters. And it's an 85, oh, whoops, I reversed that. We have an initial volume of 25 mils and an initial concentration of 85% phosphoric acid. The second volume would be the 80 mils of water plus our initial volume of 25 mils. So here we're given the water. So our second volume is 105 milliliters. And we're looking for the concentration of the diluted solution, which will be a mass percent, but we don't know yet. So if I manipulate the equation for the C2 variable, I get C2 equals C1 V1 over V2. What does C1 equal? 85. What does V1 equal? 25 mils. All over the 105 mils of water, the total resulting volume. So we get C2 equals 20.2%. And that is our answer. So here it was a little bit easier because you were given the water, but you just have to make sure to add those two volumes, because if you just used 80 in the denominator, you would get a different answer and it wouldn't be right. So, and our answer came out as a concentration expression as a percent because we already were given the concentration in a percent in the first place. So we didn't need to do any additional algebra to get that percent. Our answer was a percent. Let's look at this question. It looks pretty similar, but it's different. If 25 mils of the 85% phosphoric acid solution, and I'm giving you the density, I gave you the density both times, you didn't need it the second time, is mixed with 80 mils of water, what's the molar concentration, M, of the diluted solution? Now we have a little bit of a problem. We're given a mass percent of the phosphoric acid, but we're looking for a molar concentration. So this is a very similar problem, except I need to get this mass percent into molarity in order to calculate the molarity of the concentrated solution. So what is molarity? Molarity is moles of solute over liters of solution. So that's why you're going to need the density. An 85% phosphoric acid solution, H3PO4, has 85 grams of acid in 100 grams of solution. So what I need to do in order to make this a molarity concentration, it's almost like, in a way, changing units, except you're changing expressions, is I need to convert the acid, my solute, into moles, and I need to convert my solution in grams into liters using the density. So let me do the acid first. 85 grams of phosphoric acid, H3PO4. I need this in moles. So 1 mole of phosphoric acid, quick math here, hydrogen is 1. So 1 mole has approximately 98 grams. So we have 0.86 moles of phosphoric acid. We have 0.86 moles of the acid. Okay, that's step 1. Step 2, I need to convert the 100 grams of solution into liters. I have 100 grams of solution. Per every milliliter of solution using the density, there is 1.689 grams. And I need it in liters, not milliliters. So for every 1,000 milliliters, should be another 0 there. Let me fix that. For every 1,000 milliliters, there's 1 liter. The molarity concentration requires that the solution be in liters. So for every 1,000 milliliters, there's 1 liter. So we have 0.059 liters. So this information here can get us our molarity. And here the grams cancel, the mils cancel, and you're left with liters, and here the grams cancel, and you're left with moles. I should say grams. So to find the molarity of this concentration expression, we're going to take the moles we have of acid, 0.86 moles, over the liters of solution, 0.059 liters. So 0.86 divided by 0.059 gives us a resulting solution of 14.6 molar. Okay, that was the hard part. We had to convert the mass percent into molarity because we're looking for the molar concentration. So the concentration of the first is that 14.6 molar that we just calculated. The volume of the first is the 25 mils. We're looking for the concentration of the second, but we know the volume of the second is that 80 mils plus the 25, so 105 mils, same amount. Manipulate the expression again. You get C2 equals C1 V1, C1 V1 over V2. So C1's 14.6 molar, V1's 25, and V2's the 105 mils. So you get C2 to be 3.5. Fix that. 3.5. And this is molar, not percent. We wanted the molar concentration. So it's a 3.5 molar concentration. So we diluted it, we added water, so the higher concentrated it was the first solution, but we decreased the concentration because we diluted it with water. So just be careful here. Not too bad. Okay, our last example. A student obtains a 7.5 gram sample of calcium hydroxide with a molar concentration of 7.5 molar. What's the molar concentration of the hydroxide ion in the sample? Okay, well, let's look at calcium hydroxide. Calcium hydroxide is CaOH2. Calcium has a +2 charge. Hydroxide has a -1, so you need 2 hydroxide. When calcium hydroxide dissociates, a highly ionic compound, so it will dissociate into a solution. You're left with 1 calcium ion, but you have 2 hydroxide ions. So if you're looking for the hydroxide ion concentration in the sample, you need to take the 7.5 molar. You have 7.5 grams of the sample and it's 7.5 molar, and you need to multiply it by 2 to get the OH concentration, because you have 2 moles of hydroxide per every 1 mole of calcium hydroxide. So the molar concentration of the hydroxide ion is 15 molar, 7.5 times 2. And that's the final answer. I hope this video helped you to understand dilutions and more on concentration expressions. Future videos will be solution stoichiometry and colligative properties. Thank you for tuning in.